Okay, in this video we are going to do an example when we have we're looking at the population mean when we don't know sigma. It's unknown. So we're going to estimate the mean credit card debt for the population of U.S. households. So the data are in Chapter 8, Except File tab, Sigma Unknown Credit Cards. So let's go there. So I already have all the solutions here. I'm actually going to show you two different methods on how to do this. But I just copied and pasted the data over here because we're going to do this from scratch. So remember, the first thing we need is our point estimate. So that is the mean. So it's average. So we're going to take the average of all of our data. So right, each of these represent the credit card debt. Right, that's what we're looking at. Yeah, the credit card debt is this household or per person. So these are each one of our random samples. So this is our point estimate. It's our mean x bar. And then remember, the other thing that's different now is we have to calculate the sample standard deviation, because we're going to plug that in for the population standard deviation. So it's standard. Sorry, I can't talk in right. So it's standard deviation dot s because we want it for the sample. So let's highlight our data. Right, and so here is our standard deviation for the sample. So we have that information. So we have our point estimate, we have our standard deviation, so we can continue on with some of the information we need. So we need to know the sample size, right? There's a few ways we can do this. I know just by looking at this, right, if this is the bottom observation, it's in row 71, so we know we have 70, our sample size is 70 because the first cell up at the top is, right, it's the title of the column. So if there's 71 rows, that means there's 70 observations because the first one is a title. Something else you can do is you can use the equals count A function. So that counts the number of cells in a range that are not empty. So we know there's no missing values. So we basically can just highlight all of the data cells and it will give us 70. So there's a couple different ways you can do that. Degrees of freedom now, right? We need to know that. So that's just equal to our sample size minus 1. We already know the mean and the sample standard deviation, so let's just copy and paste those. I like to have them all in one place, but you don't have to do this. So we have that. So then the next thing we're going to want to do is we have our point estimate. So now we have to add and subtract the margin of error, which is created by multiplying, right, our t-value and then our standard error. So let's calculate our standard error, which is just our standard deviation divided by the square root of n, right? And remember, before we just plug in the population standard deviation, but this time we don't have that, we had to estimate it, so we plugged in our sample standard deviation, right? And so then the other thing that we have to do is we have to figure out that t-value. So this one is a new function we haven't learned about yet. So it's called t, right, because it's a t distribution. It's the inverse. And if you look at the description, it says returns the two-tailed inverse of the student's t distribution. So I know this is a little confusing, but we're going to plug in 0.05 for that, because it's asking for the probability, 0.05, and then the degrees of freedom. So it's not 0.025. I know that's a little confusing like it was in the past. And then we get 1.99. So we have that. So that means we can now calculate our margin of error, because remember, that's just our t-value, right, multiplied by our standard error. And now we can use that to create our upper and lower bounds for our interval estimate, right? It's just our point estimate, right, our mean from our sample, plus the margin of error, and then also our point estimate minus the margin of error. And that right there is our interval. So I'm just looking over here. That's what we had calculated before. So that's one way to do that. There's also another way that's a little bit quicker. So what you can do is you can go up to Data, up here. Go to data analysis under the analysis section. If you don't see this, you should see this by now, but in case you don't, this is an add-on analysis, so you'd have to get that. And then when you hit data analysis, a box should appear. You can go to descriptive statistics and hit OK. Input range, so now we have to select our data. So I'm going to select our data. The label in the first row, I'm going to check that box because I did have it highlighted. Output range, I'm going to check that and then put my cursor in that box and select where I want the output to go. I'm going to select right here, I want it to be next to what we just calculated so we can compare. You want to hit summary statistics and then confidence level for the mean. Again, it's 95%, but if you're asked for like the 90% or the 99% confidence level, you can change that accordingly, but ours is a 95th, so we're going to leave that there and just hit OK. And then you get your output. So if you'll notice, it's very similar to what we've already calculated, right? The mean, we already have that. That's right here. The standard error, right? We already have that. We calculated that. Some of these other things we didn't. The standard deviation, right? We calculated that. And then if you look at the confidence level right there, that 95, that actually ends up being the margin of error, right? So we have that right there, margin of error. So that took in the 95% confidence level, right, which we needed to know what value to get for our t. So it took basically your standard error that it calculated right there, but it had to know what to multiply it by, what t value here, which is where we had to plug in the sample size for it, right? The degrees of freedom, we had to know that, and we also had to know the alpha. So that's all given to us. So then basically we could just create our intervals by just adding to the mean this value or subtracting this value from the mean. So that's basically all it is, all there is to it. It's very similar to everything we've done so far. So in terms of interpretation, the last part, very important obviously, is what we found is that we can be, again, 95% confident that the true population mean is within our interval, right? A little over $8,000 to a little over $10,000. So basically that is, what was it, the average credit card debt for U.S. households is $8,000 to $10,000. That's a lot of money. So real quick, just a decision tree, right? Can the population standard deviation be assumed, right? If we know it, right, we're going to use this equation, right? We use Z, we use the standard normal distribution, and we just plug in sigma that we know. If we don't know it or we can't assume it, right, we have to use the sample standard deviation S to estimate the population standard deviation, which is right there. And then we also have to use the t-distribution instead of the standard normal distribution. So for that we have to have, the sample size. We take our sample size n minus 1. That gives us the degrees of freedom. We have to know degrees of freedom because that's going to tell us basically which t-distribution we use. And that's important because the different t-distributions have different areas in their tail, different areas under the curve for different parts of it. So it affects the probabilities that we get.